Welcome to a lesson on solving a linear first-order differential equation. If we do have a linear first-order differential equation, then it must fit this form here, which is the standard form of a linear first-order differential equation. So once we have the equation in this form, we're going to multiply through by a function called an integrating factor that's going to make solving this differential equation a lot easier. So next we'll find the integrating factor, which is the function mu of x equals e raised to the power of the integral of p of x integrated with respect to x. So notice that p of x, this function here, is the function being multiplied by y. So once we find the integrating factor, we'll multiply both sides of the equation by mu of x, given here. And once we have the differential equation in this form, what we should notice is that the left side of the differential equation, or this side here, is now equal to the derivative of the product of the integrating factor mu of x and y. So this left side here is equal to this derivative here, which means this derivative must also equal the right side of the equation given here, which is the integrating factor times the function f of x. So once we have the equation in this form here, we'll integrate both sides of the equation and then solve for y. So let's go ahead and take a look at our first example. The first thing we need to do is make sure that we do have a linear first-order differential equation that fits this form here. And we do. Next we want to identify the function p of x, which again is being multiplied by y here. So in this case, p of x is equal to 2 divided by x. And now once we have p of x, we can find the integrating factor given here. So mu of x, our integrating factor, is going to be equal to e raised to the power of the integral of p of x, which is 2 divided by x. I'm going to go ahead and factor the 2 out. So we'd have 2 times the integral of 1 over x dx. Well, the integral of 1 over x is just going to be natural log x. So this is equal to e raised to the power of 2 natural log x. We don't want to leave it in this form though. We'll now apply the power property of logarithms and move this 2 here to the exponent on this x. So this is equal to e raised to the power of natural log x squared. And now that simplifies even further. Remember, if we have e raised to the power of log e, or natural log, this simplifies nicely just to x squared. So our integrating factor, mu of x, is equal to x squared. Now we'll multiply both sides of the differential equation by x squared. So that would give us x squared times dy dx plus x squared times 2 over x times y equals x squared times the quantity x minus 1. Now let's go ahead and simplify this a little bit. This would be over 1. So here we'll have 1 factor of x simplify out. So we'd have x squared dy dx plus, this would now just be 2xy equals, let's go ahead and distribute here, we'd have x cubed minus x squared. Now that we've multiplied by the integrating factor, what's special about this is that the left side of the equation, this side here, is now equal to the derivative of the integrating factor, which is x squared, multiplied by y. So let's go ahead and check this by applying the product rule. We'd have the first function, x squared, times the derivative of y with respect to x, which is dy dx, plus the second function, which is y, times the derivative of x squared, which would be 2x. So that's true. And since this is equal to the derivative here, the derivative must also be equal to the right side, so we can set this equal to x cubed minus x squared. Now that we've done this, we'll now integrate both sides of the equation with respect to x and solve for y. So looking at the left side, the integral and the derivative are going to undo each other, so we're left with just x squared y equals, integrating this back to x, we would have x to the fourth divided by 4, or 1/4 x to the fourth, minus x to the third divided by 3, or 1/3 x to the third, plus our constant of integration. And now to solve this for y, we just need to divide both sides of the equation by x squared. Let's go ahead and finish this on the next slide. So on the left side, we just have y. On the right side, we're dividing each term by x squared, so we'll be subtracting the exponents. So we'll have 1/4 x to the second. Then we'll have minus 1/3 x plus c divided by x squared. And this would be the general solution to our differential equation. Let's take a look at a second example. So the first step again is to make sure that this linear first order differential equation fits this form here. Notice how we just went dy dx here, and we have x times dy dx. So our first step is going to be to divide everything by x. So we'd have dy dx minus 4 divided by x times y equals, we'd have x to the fifth e to the x. Again, we divided everything by x. Next step, we want to identify our function p of x, which is being multiplied by y. So p of x is equal to negative 4 divided by x. So now we can find our integrating factor, mu of x. It's going to be equal to e raised to the power of the integral of p of x dx. We'll go ahead and factor out the negative 4. So we'll have negative 4 times the integral of 1 over x dx. The integral of 1 over x, just like last time, is natural log x. So we'll have e raised to the power of negative 4 natural log x. We'll go ahead and apply the power property here. So we have e raised to the power of natural log x to the negative 4. And again, the base here is e. The base of the log is also e, so this simplifies nicely to x to the power of negative 4. So our integrating factor, mu of x, is equal to x to the negative fourth. So now we're going to multiply both sides of our differential equation here by x to the negative 4. So we'll have x to the negative 4 dy dx minus x to the negative 4 times 4 over x times y equals x to the negative 4 times x to the fifth e to the x. Let's go ahead and simplify this. X to the negative 4 dy dx minus, now here if we move this down to the denominator, it would be x to the fourth. So we'll have 4 all over x to the positive fifth times y must equal, here we'll add the exponents because we're multiplying. That would just be x e to the x. So again, the big connection here is that now the left side of this equation, or this side here, is equal to the derivative of the integrating factor times y. Well, the integrating factor was x to the negative 4, and then times y. So these two are equal. Let's go ahead and check it by applying the product rule. The first times the derivative of the second, that looks good, plus the second, which is the y, times the derivative of the first, and that's the reason why it's minus, because we'd multiply by negative 4 and then subtract 1, that'd be x to the negative fifth, which in the denominator is x to the positive 5. So that looks good. And since these are equal, this derivative must also equal the right side here, which is x times e to the x. And now the last step is integrate both sides and solve for y. Let's go ahead and do that on the next slide. So again, now we're going to integrate both sides with respect to x. So the integral and derivative will undo each other, so we'll have x to the negative 4y. And to integrate here, we have to apply integration by parts. So just to review, here's the formula for integration by parts. So to integrate here, we would let u equal x. So du is equal to 1 dx, and dv is equal to e to the x dx. So if we integrate to find v, the integral of e to the x with respect to x is just e to the x. So now we can apply integration by parts. We have u times v, which is x times e to the x, minus the integral of v du. Well, v is e to the x, and du is just dx, so we have e to the x dx. And now this is much easier to integrate. So we have x to the negative 4y equals x e to the x minus e to the x plus c. Now we could divide both sides by x to the negative 4, but instead let's go ahead and multiply by x to the 4th. Remember, we add these exponents, x to the 0 would be equal to 1. So we have y equals x to the 5th e to the x minus x to the 4th e to the x plus c times x to the 4th. Okay, I hope you found this video helpful. We'll take a look at some more examples in the next few videos.